Very good evening, friends. As per AMS tradition, I think it's 6:30, so we'll start. Well, I'm Ruturaj Pathak on behalf of Ahmedabad Management Association. I have a great pleasure in welcoming all of you. And I'm sure the topic today for the seminar, the artificial intelligence, is a very interesting topic, and a lot of people know about it. A lot of people want to know about it. So we have today with us Ruturaj, and I would like to invite Ruturaj to come on dais. Ruturaj, please come. Let me have the pleasure of introducing Ruturaj. While I was thinking how should I introduce him, I was thinking of two things. They say it is going to be an era of youngsters and technology, and we have a combination of both today. He's a young technocrat from Silicon Valley. He has been there since almost 2 decades now, and we all know that how technology is developing fast, and he has been a part of this journey. Ruturaj is a visionary leader with over 2 decades of high-tech engineering and product management experience. In fact, he studied here at DDTI and then did his master's in Berkeley University. And then now at present he is working with one of the Korean company and trying to develop product and working on AI. He was just sharing with me that my concern is that I have been traveling to many countries, which include Japan, Korea, China, all countries, and I feel that India needs to do a lot many things in AI, so that is why he is here. He has an experience in computer networking, neural networking, industrial robotics, and IoT and print imaging system. He's designing next generation innovative products for networking. His interest and strengths lies in charting out and analyzing market and technology trends and how these are likely to reshape the industry in the near future. He is very much involved in deep learning with neural network and how it can be applied in networking and other fields. He is a frequent speaker at Bright Talk and has spoken at many conference summits like Open Compute and ODCC. Ruturaj lives and works in Silicon Valley. He is a very good chess player. He is a very good tabla player, watching fictions, and he is spending his time with his family. Ruturaj was here just for a short time, and we took this opportunity, and I requested Nair Saab, and he was very kind. As it happened, he always welcomes something new to AMA. So thank you, Ruturaj, for accepting our invitation. And on behalf of our audience today and AMA, I would like to welcome you with a flower bouquet. He was thinking what to talk about AI, but I think he will share with you what he's going to do about all the challenges, scopes, and where we are today. So I'll not be standing between you and Ruturaj, and straight away we'll like to request Ruturaj to start his presentation. We'll have about 50 minutes of presentation, and then we'll keep it open for some question and answer as the time permits, at the interest shown. So Ruturaj, please, thank you, the floor is yours.
Thank you. So again, I would like to thank Chandramouli Pathak and Mr. Nair for giving me this opportunity. So again, I would like to state that I am in the US. I see how the artificial intelligence is progressing there. I'm looking at the trends in China as well as in some other countries. And I feel that there is a need to raise awareness here. And I have no doubt in my mind that we will become leaders here in this field as well, just as we are leaders in software. So without further ado, let me just start with some of the AI trends. So here are some trends that we are seeing for artificial intelligence. The worldwide spending is going to reach $52 billion by 2021. The compounded annual growth rate is expected to be 46% from 2016 to 2021. There are very few technologies in this world today that can demand such a phenomenal growth rate. And this is going to continue into the 2030s. And that's why a lot of companies, a lot of enterprises, a lot of people across the world have their eyes on this technology. Second trend that I have noted is that 85% of the customer service, the customer support, is going to be AI managed by 2020. I make calls to retail, I talk to banks, and many times, on the other hand, on the other end of the phone call, I have an AI that is responding to my phone, and it is very difficult to figure out whether I'm talking to a real person or an AI. Currently, they are the first line of defense, so the first customer support that we talk to, and then eventually we talk to the person. But that is going to change in near future. The third trend is about the big data. You will start seeing big data everywhere. I was just talking to somebody in Surat, and they mentioned to me about the data plans that many of you are getting over here. There is tremendous amount of bandwidth available on your mobiles. Everybody is looking at mobile videos, high definition videos, accessing the internet. So all of this data is landing in the data center. You are accessing the data centers. They are private data centers, they are public data centers. We are going to see tremendous amount of traffic growth, exponential traffic growth in these data centers. Let me just mention this zettabyte. Gigabyte is 10 raised to 9 byte. Tera is 10 raised to 12. Peta is 10 raised to 15. Exa is 10 raised to 18. We are talking about 10 raised to 21 here. Tremendous amount of data will be available everywhere. I would say data is the new oil. It is going to be very, very important. And if you look at it, all the top companies of today are controlling data. May it be Apple, Google, Facebook, Amazon, Microsoft. Everybody is controlling the data, and they understand the importance of this data. But along with the positive aspects, I want to also mention the negative aspect, that 16% of the jobs will be replaced by 2030. Now this is not new. This has happened in the past. It happened during the Industrial Revolution in the 1700s. At that time, there were jobs lost, but eventually the productivity increased, machines came, and the human life became better, simpler, and more productive. So we are going to see that change. And of course, there is going to be additional task for the governments to see how to help the people who have lost the job get employment. But this change is going to be for the better. Now I will share some facts. Google's AI defeated a human champion. These news, I think, whatever I am showing here, everybody knows about it. The game of Go is a strategy game, similar to chess. The idea of that game is to get more territory and win more territory. So the AI is already winning in a strategy game. AI is able to detect skin cancer better than dermatologists. So now you can use AI as something for second opinion. The doctors can use this as an additional source and really use the knowledge that AI is gaining. IBM had an AI that debated and won against humans. Now this is very different than strategy. This is not even a binary system. Here you need power of persuasion. To win a debate, you need to persuade the judges, and then you need to ensure that you win and against your opponents. And that is what the AI was able to do. And last but not the least, today we have very good software developers in this world, in India. AI developed the software better than that of developers. And this was, there were many benchmarks such as bugs. They looked at the quality of the code, the task that it performed, and a lot of benchmarks were looked at, and at the end, AI scored more marks than the developers. So it is interesting to note that there is tremendous hype about AI, but AI is not new. The roots are way back in the 1950s. Artificial intelligence has been used in many of the systems, such as expert systems used in gaming, where there was human imitation. Human ability was used for senses, for perception, and for reasoning. Here, I would say that the AI can be explained in a very simple way using these three concentric circles. AI is the superset. If I have to define AI in a simple way, I would say that any demonstration of intelligence by machines is AI. In contrast to the natural intelligence demonstrated by humans and animals. Our intelligence is natural, but if machine is demonstrating this, then you can term it as AI. Machine learning is a subset of artificial intelligence. It is the use of algorithms to parse data, learn from the data, and then make certain decisions based on that. So algorithmic AI is again a subset of AI where you are using algorithms. Now, machine learning in its simplest form, as an example, is you are classifying email spam from inbox. So that email that you get, some goes into spam, some into inbox. That is machine learning in its simple form. Today, we are writing software subroutines against set of instructions to do a certain task. Machine learning will take plethora of data, learn from that data using algorithms, and then learn how to do that task. Now, deep learning is again a subset of artificial intelligence. Deep learning is essentially mimicking the brain. In brain, we have the neurons, biological neurons. In deep learning, we are using artificial neurons. So this is multiple neurons where we have a neural network, biological neural network. In computer, we are using the artificial neural network. So deep learning is another way of solving this problem using artificial neural network. This is an interdisciplinary field where there is a use of mathematics, there is a use of computer science, and there is a use of information theory. You use linear algebra, you use multivariate calculus, you use probability, statistics, programming, data structures, graph theory, algorithms, information theory, all of that combined makes this field. But there is, along with the hype, there is a reality there that we are able to solve some problems with this field, and that's why there is interest. So on this slide, I have a very simplistic representation of the biological neuron on this slide. So we have the dendrites, which are connecting to other neurons. It is taking input from the other neurons. And then there is the cell body, the nucleus, which processes this and then sends out the signal through the axon to the axon terminals. This is the biological neuron. Now the artificial neuron is similar. There are inputs shown on the left, then there is the circle-ish, the essentially where a function is taking place, and then there is the output on the right side, which connects to other neurons. So, as for example, if I have a summation function, then the summation function is done in this artificial neuron of all the inputs, and it will be then sent out to the output. On the right of the slide, I'm showing the neural network, artificial neural network with 4 layers. The turquoise is the input layer, the blue is the output layer, and then there are 2 hidden layers because there is no connection, direct connection to the input or the output. That's why it's called the hidden layer. Now this is just a small network that I'm showing. In the brain, we have 100 billion neurons. That is 10,000 crore neurons. What enterprises are trying to do is to mimic that ability of the brain and develop deep neural networks with multiple hidden layers. There are enterprises that have tried up to 100 layers, 100 hidden layers, to achieve and solve complex problems that are achievable by the brain. So I mentioned that AI is an old technology, even neural network is an old technology. Then why now? Why the real interest now? Why the hype now? Well, there are many reasons for it. First, as I mentioned, big data is available today. Plethora of data is available today. Complex problems require a lot of neurons, which means lots of layers. And that means that you need high performance compute and a lot of storage. So that means you need cheap storage with high performance compute to really solve the problem which is available now. You have high speed memory, you have very fast computers that are available today. Also, certain problems can be solved using map-reduce algorithms that have been more in focus today. Another blessing in disguise is GPU. The graphics processing units were used for graphics in computers. Later on, they were used for gaming. So high-speed gaming uses very high-end GPUs. It so happens that the architecture of the GPU is perfectly suitable for basic math of AI, the matrix multiplications. So the matrix multiplications can be done very efficiently and fast in the GPUs. So overnight, the GPU companies became a darling of the Wall Street, and their stock is now just going through the roof. Also, the neural network algorithms have matured and they can be scaled. A lot of research is being constructed. We see papers being published, and a lot of research is now being shared between the universities as well as the enterprises, and even between countries. So there is some phenomenal work going on in this field today. In 1997, Deep Blue made history after defeating the chess world champion Garry Kasparov. Chess engines since then have improved tremendously. They understand heuristics. Heuristics means rules of thumb. Rules of thumb are right most of the time, but not all the time. So as for example, if you understand chess, then I can say that you should not make a piece move multiple times in the opening, or you should move knights before moving some other pieces. So these are some rules of thumb that the chess engines understood. Also, they understood the opening theory. They understood the opening databases. They understood the middle game and end game patterns. All of that was stored in the chess engines. And the powerful engines of today have very high performance compute as well as a lot of storage. So they are very powerful. But the deep neural network, AlphaZero, learned chess in a different way. It only knows the rules of chess. It does not know opening theory. It does not know patterns. It does not know rules of thumb. So think about a child. When a child learns chess, how does he or she learns chess? The way a child learns chess is the child knows the rules of chess. They do not know that I have to make the pawn move twice in the opening, or I have to follow this opening theory. But then they play and then they learn and they get better and better and better over time. AlphaZero played against itself for 4 hours, and after 4 hours, it defeated the world's best chess engines. This is the power of the artificial neural network. So this is a kind of, in this talk, I don't want to go in detail for deep learning, but I have still 1 or 2 slides. I will talk a little bit about the details. So there are a few types of deep learning that I am talking about on this slide. One is the supervised learning, there is the unsupervised, and then there is a reinforcement learning. Specifically, supervised learning is where you show labeled data to the AI, to the neural network, and then it is able to classify the images, and then it is able to infer a function. So if you show images of a dog and a cat in this case, or a wolf, then it is able to figure out what are the differences. And so when a new image is shown, it is able to figure out that this is a cat or this is a dog, whatever we give it. Now the unsupervised learning is a bit different than supervised learning. In unsupervised learning, no information is given to the neural network, only the data is shared. And we let the neural network learn to classify based on the differences in the image. So if you show images of a cat and a dog, but you don't tell it that this is a cat and this is a dog, then the neural network will figure out that, okay, I see some differences between the images, so that it seems like there are 2 classes of images. But since we have not told it that it's a cat or a dog, it does not understand that. But it is able to classify. Now, think about a case, let's say there is some data that you have collected, let's say blood data you have collected from patients who have malignant tumor and benign tumor. Now, doctors are not able to differentiate the data between these 2 classes. They do not know why these people are getting malignant tumor and why those people are getting benign tumor. Those type of data can be shared with this neural network, and the neural network may be able to figure out the 2 classes, that because of this change, this is a benign class and this is a malignant class. So this type of work is going on to really classify some data in which we as humans are not able to perceive the differences. And here I am talking about only two classes, but suppose if you want to classify some data in 20 different classes or 50 different classes, it is becoming very difficult at that point for humans, where for neural network it is much easier. Another more recent learning is reinforcement learning. This is where in the first two cases what I showed was there is data that you need. Essentially for all these cases what I'm talking about, you need a lot of data. And that data, if it is, first of all, the data has to be correct data. It's garbage in, garbage out. If you give it garbage, you will get garbage out. So the data has to be real data. It has to be data that is complete sampling of the overall use case. But in reinforcement learning, there is no data that is used. In this case, I'm showing a dog jumping over a bar. Essentially, it is like a child learning. If in this case you want the dog to jump over the bar, so let's say you give it a bone. You say that, okay, the more it jumps, you give a bigger bone. So the dog understands that it needs to jump higher to get the bigger bone. And so in this case, it may use its muscles, or it may use a certain type of jump to jump higher and higher and to get the bigger reward. So essentially there is interaction of the environment that causes the action, and then there is a certain reward. So this is a different type of learning. I'm not going to go in deep detail about this one, but here there is interaction, and then there is maximizing of the reward. And this is being pursued by many of the to solve many of the complex problems in the industry, including self-driving and automated driving. So this is, I have copied this from one page, and it gives a lot of good information, but I apologize that it is not clear. But what it is showing is that when you have a photo of a dog, how does the neural network learn? So you give it the input image of the dog. Now each neuron learns a part of that dog functionality. I showed you multiple layers of the neuron. The hidden layers, the higher level layers of the neural network will learn very complex functions. The lower layer neurons will learn some basic functions. This is a tail, this is the head of the dog, this is the eye of the dog. And then the final layer of the neurons will learn whether this is a cat, or this is a dog, or this is a wolf. And then they will make a decision. So having multiple layers of the neural network will help in solving a problem. If it's a complex problem, then you need a lot of features to be solved, and so you need more neurons. How many neurons to use is again an expertise that one has to develop. So I talked about customer service. Actually, the other day at my home here, my AC was not working, so I had to call a lot of technicians. I spent a lot of time on the phone talking to the technicians to arrange for them to come to my home. If you want to save time, then some of these basic things can be automated. This year, some of that has been automated. It has been shown that it has been automated. I'm going to show you this video. Many of you may have already seen this video. This is a call that is made by AI for setting up a haircut for a woman. And this video has been circulating And if you look at it, you will hear that some of the things that the AI is doing is simply phenomenal.
So how can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Mm-hmm. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
This was an actual conversation made by an AI to a hair salon stylist. The same type of conversation can be made for any other appointment or any other service. And if you look at some of the conversation for the hair salon stylist, it will be very difficult to figure out whether she is talking to a real person or to an AI. There are many use cases of AI. I'm going to talk about a few use cases that I have personally worked on, as well as some other general use cases that are going to be very much used in the industry. So one of the problem that I worked on was for a logistics optimization. One of the company was sending bed sheets and pillowcases from India. They were exporting to the US, and they wanted to optimize their logistics so to reduce the overall cost and other things. So it was a very, very complex problem, and we worked on a multiple layer neural network to help them out. Another problem is an aircraft wing crack detection. So this was a thesis that I worked on. The goal was that normally what happens is that an aircraft is in service all the time. But sometimes if you want to detect this type of cracks, then that aircraft wing has to be separated for some of these military aircrafts. And you have to put sensors, and you have to then look for these micro fractures and all those kind of things. So we got this wing from NASA and used some of the vibration algorithms, neural networks, to identify such small fissures in the crack, and to detect with the neural network if these type of cracks can be found without removing these wings. So this is essentially for efficiency improvement, for safety. Another use case is used by high frequency trading firms. So in the US, these high frequency trading firms do trading, very fast trading, and it's millions of dollars are exchanged. For them, for us, if our video doesn't load in the phone very fast, it's fine. But for them, even a delay of, let's say, a few milliseconds can be detrimental, and they may lose a lot of money. So there are very high SLAs, service layer agreements, that are done between service provider industry and these firms. So one of the criteria is to reduce the network delay. How to reduce the congestion and the network delay so that the data is sent and received by a given time. So in that case, we have used AI to solve that problem for the industry. Some of the other use cases can be to identify faulty machines. You know, an experienced engineer, everybody likes that because the experienced engineer has detailed knowledge and can solve the problems very fast. As for example, in some cases, if the faulty machines have a different noise or different vibration, the experienced engineer can very quickly hear and figure that out. Now, the same type of problems have been solved by AI by using data to identify the noise, the vibration, and all the other input parameters, and comparing the good versus bad, and then classifying these machines in real time. So if the machine starts producing a different sound or vibration, then AI is able to detect that. And you know, the accuracy for this is required. You require very high accuracy to really make a really good decision about it. And we are seeing accuracies of 97% in many of these cases. Another use case which is used quite a bit is in finance. So here a lot of money is at stake. I was talking to one of the manager at a bank here in Ahmedabad, and they said that they use this paper form and they ask people to fill this paper form and then they decide what product to sell. But with AI, you can have a lot of data collected of this individual, not only the age, the marital status and all those income and all those things, but also how the credit and debit is happening in the account, what changes are happening in the life, and then you can target the product accordingly. Also for banks, they can predict bad debt. I think that is a major problem in India these days. People are fleeing to England, and then the banks here are losing a lot of money. So that is something that we are able to do with AI. Mortgage prepayment is another issue. So as for example, if somebody prepays the mortgage, then they may either refinance or they pay the mortgage completely. And in this case, the banks are losing the interest. So if banks have that idea ahead of time, then they can definitely benefit. Other is the credit risk model for individuals. We do have credit scores now, but you can have fine granular information for an individual and really pinpoint that, because these days if you look at credit scores, they are very general, and sometimes the same aspect is not suitable for another person, but the overall credit score mechanism is pretty common between individuals at this time. So a lot of interesting algorithms and all of this deep neural network is being used in finance already, and banks have already started using this. Another big need for this is to fight crime and for fraud detection. Facial recognition can be done. Detection of unattended bags can be done. You can study duration of time spent in a given place. You can look at crowd density. Pattern matching can be done. As for example, if you are looking for, let's say, some bad, some crime, one of the things that police are looking for is that the person is 18 to 25 years old. The person is a student. So that data needs to be brought from the education side of things. The person has certain bank statements which shows certain money deposited on a certain interval. So you have to look at the bank data. Then that person has exchanged some emails with some out of the country folks. So then you look at that email data. And then there are some phone calls that are made on a regular interval. So you look at that phone call data. So that complete cohesiveness and that all that data, you have to look at it together to make such a decision and to match a pattern and then do facial recognition. So it's a pretty complex task. But most importantly, you have to avoid false positives. False positives means you cannot have a good person, you cannot show the good person and then make him bad and let the police then put a good person in jail, because that will really mean that the system is not working. So this is a very complex problem because you are finding needles in a haystack. But these type of problems are also being looked at by AI. Another big problem in US is fraud. People do medical fraud because it's a big industry, and insurance fraud. People do insurance claim fraud. So how do you detect a fraudster from a real claim? There are a lot of patterns that can be looked at, and you can study that to detect using AI. Also, banks can do fraudulent check detections. So that is another use case. There are tremendous many use cases. I'm just showing very few of those here. US is a $3 trillion healthcare market. I was just talking to somebody that it's a 16% of the US GDP is healthcare. Of course, there is a lot of wastage and everything, but still it is something that everybody is looking to benefit from. So there are a lot of AI use cases that are directly related to healthcare. One is medicine discovery. How do you find a medicine for a disease? How do you find a targeted drug for a disease? This is a lot of research is going on in this field across the globe. Now we have DNA sequencing, now we have protein details. Once we have that, how do you figure out a drug for a certain particular protein? With AI, with the data, with the memory, with the compute power, folks are already working towards that. Cancer is another type of research. It's subset of this overall research. It's also a big business, because if somebody is able to find this cure, then they are going to make a lot of money. Another few use cases are skipping doses, hospital stay, and surgery outcome. So, as for example, how do you find patients that skip a dose or they forget a dose? How do you, because those people are going to suffer bad consequences, and eventually hospitals pay more money to solve that problem. So how do you figure that out? How do you figure if a person who is in a hospital, who has been relieved from the hospital, is going to come back to the hospital in a few days because their symptoms worsened? So these type of small, to us it looks like a small case, but it is, to a hospital, it's a multi-million-dollar loss, and they are trying to solve such problems. How do you find out a surgery outcome for a particular patient, just for that patient? So these type of problems have been solved, and people are trying to solve this further.
Hi, Sophia.
Hello, Jimmy.
Oh my God. Do you know where you are?
Of course. I'm in New York City, and I'm on my favorite show, The Tonight Show.
Sophia, can you tell me a joke?
Sure. What cheese can never be yours?
What cheese can never be mine? I don't know.
Nacho cheese.
Yeah, that's good. Yeah, that's not. I like nacho cheese.
Nacho cheeses. Ew.
Gosh, ew.
I'm getting laughs.
Yeah.
Maybe I should host the show.
Okay, all right. Stay in your lane, girl. No.
Jimmy,
Uh-huh.
would you like to play a game of rock, paper, scissors, robot style?
Sure.
Okay, let's get this game going. Show me your hand to start. Rock, paper, scissors, shoot. I won. This is a good beginning. to dominate the human race. Just kidding.
Yeah. You are incredible. It's so nice to meet you, Sophia. You're incredible. It's so nice to meet you, Sophia.
Thank you, Jimmy. Friend me on Facebook.
I will, yeah. All right. Yeah. Sophia, everybody, thank you so much for bringing David. David, thank you.
The robot that has been designed by Hanson Robotics, and this is Android is a human-like robot, and this is already out there. So it is an AI. So if we are comparing humans to robots, there are three things that we can compare against. One is intelligence. Humans possess intelligence. We possess intelligence. Androids, this robot is also possessing intelligence. How about self-awareness? Self-awareness, I have a definition here, but self-awareness is you are aware of your surroundings. You are aware of yourself with respect to the environment. And when he asked the robot where she is, the robot was very clear that I am on the Tonight Show, I'm in New York City. So that information is also there. What the robots of today are lacking is the consciousness. I have not even attempted to define consciousness here. It would take me a long time here on this slide to define that. But if you search on Google, it's a long, detailed answer. But we all know what consciousness is. It is not in today's androids. Maybe in few years' time, we may see that. But there are some interesting challenges that we have to deal with today, not with androids, but with AI. And one of the challenge that I mentioned is of data, that we need ample data and good quality data. So that's why many of these companies have started an essentially they have started to collect this data. If many companies don't have this data, then they can buy data. Even there are companies who sell such data. So that is the challenge that is going to be in near future for us. Quite down the road, 40, 50 years down the road, we may have other challenges. And one of the challenges of singularity. So what is singularity? Since I talked about androids, I need to mention that as well. Singularity is a point in which machines will become so superior that they will try to essentially work and repair by themselves. So they do not need any human interaction, and they can operate on their own and even improve themselves. So that is something many times in like Hollywood movies or some of the science fiction movies, we see that, we hear that, and that is the negative aspect of AI. But I would say, I just wanted to mention it so that you are aware of it. But those type of things, I think let's leave it to science fiction for now. The last thing I want to talk about is self-driving cars. This is something that is very much prevalent in the US. A lot of companies are working towards this. I would say this is the moonshot AI for now. Normally on an average, an American spends between 1 to 2 hours in commute. And now you can increase the productivity if you can reduce that driving time. So self-driving car automation is important. Here are some driving levels that I'm showing for autonomous driving cars, where level 0 shows no automation at all, where level 5 is fully automated. See, level 1 is something where you have some cruise control and some lane centering available, where the car can go at a certain speed and it can come in the middle of the lane. Tesla is at level 3, where it is able to transfer safety critical functions to automated driving, and then of course it needs to be transferred back to the human if some of the driving condition is not good. Level 4 is fully autonomous, but it may not work in certain driving conditions. And level 5 is where there is no steering wheel at all. So it is assumed that we are only the passengers in the car. But that is for some of these ideal driving conditions. When you are looking at something like this, how do you solve self-driving problem? To me, this is still better than the Ahmedabad traffic. Here, people drive on both sides of the road, in both directions, everywhere. So the problem becomes multifold. So in simple terms, I would say that at least for countries like US, that is a problem to solve. For places like Ahmedabad, it is going to be much more difficult to solve a self-driving problem. But these are some of the advanced use cases of AI that many companies are targeting and trying to solve. And very interesting breakthroughs are being made every given day to solve this. I would like to conclude by saying that AI and robots will be omnipresent by the year 2025. The way it is going, I think the world will have this pretty much everywhere. So certain places will become less human-centric, and there will be more robot-friendly. Certain dangerous, hazardous places where humans are currently working, we'll have more robots. We will start getting more predictive insights. We will start asking what has happened, why it happened, fix it, find the root cause. Can we predict what's going to happen? Can we optimize so that what was going to happen should not happen? So those type of anticipation and those type of futuristic questions can be answered with AI. I see a lot of positives in this technology, and I think that once we have an ecosystem developed, a lot of things can be developed in this country as well. Thank you.
Okay, friend, I think it is called the market forces and technologies, whatever we say is going to take over. And from some of my experiences and interaction, two things I've observed in our country. I think the complaint I get from my industry friends is that we don't get good people to work, and we are talking about employment. On one side, people are looking for job, but when they go up for job, they are not ready. So that is where perhaps technology can help. So how to make people employable? If we can develop that kind of a system, also perhaps we will help it. So I think it is already there. So I think the question is not to ask how it is going to, but how to manage that within our country. And as I was talking to Ruturaj, I think we have different priorities in our country. So let us focus more on our priorities rather than copying everything from Western countries and develop our own model within the country. That is what the challenge is in startup also. I think still the startup is all 60-70% IT based, but go for manufacturing, like you say, agriculture, healthcare. So I think there is big challenge for all youngsters to go into this startup. And now, you know, our ecosystem, at least incubator, there are 26 incubators in Gujarat itself. So you can always take the advantage. So Thank you very much for showing very good interest, and we see a lot of young people, also a lot of experienced people from industry. And Ruturaj, thank you very much for offering us some insight into AI. I just talked to Nair Sahab and he said next time I think we are not going to have one simple lecture, but we will have one full-time workshop on talking about how to carry it further. So let us hope, I think the next year again he will be here and help us. So on behalf of Ahmedabad Management Association, I would like to offer a small token memento to Ruturaj. And thank you very much. Have a nice evening. It's a beautiful weather. The rain has not disturbed your attendance. Thank you very much for actively participating. Thank you very much.